Hi everyone, this video is a summary of testbed integration activities for the TwinRAN project into the Eurocom facility. All of the developed components in this project are publicly available on GitHub repositories, and the deployments that was done are also available in the packages section. To give you an overview of the testbed setup, the bottom portion, which includes the radio access network, core network, and the experimenters portal, is on the Eurocom testbed. And we log in through the experimenters portal to create our own instance of it. And then we deploy an XApp for each near real-time intelligent controller, which is 1 in this scenario. But before doing that, we first have to deploy the digital twin as a service. Here is the Docker Compose file, which contains all of the containers with all of their dependencies between each other and health checks and environment variables and configurations. We wait for all of the instances to be healthy. After that, now we have a empty digital twin dashboard because we have not yet connected a XApp to it. So we log in to do that. Here is the definition for our XApp deployment. It fetches the container image from GitHub, and it has a configuration to our Kafka message broker. We select that configuration. And additionally, we have to pass in the location of the FlexRec as a file, which is just a key value that contains the IP address to the FlexRec. We create our XApp and wait for it to be healthy. After that, we are ready to onboard user equipment, so we use the traffic generation tool. On the right side, we have our empty dashboard because currently there is no user equipments. To remediate that, we create the first one. After it synchronizes, we are able to see that we have one G-Node-B instance that has one user equipment connected to it. Then we add another one. Now that we are sure that the XApp is working, for sending measurements, we add 2 more. We now have 4 user equipments in total, so we use the first user equipment and configure it to generate downlink network traffic. And then we configure the second one to generate uplink traffic. We run this scenario and we are able to check our first user equipment with which we generated downlink traffic. We see that it has 6 megabit per second traffic throughput currently, and using one of the models that take 7 latest throughput values as input, we predict the next value, which comes around to 6 megabit per second again. We are also able to see the overall throughput data points that we have collected for this scenario. And for the user equipment too, we have uplink direction throughput values. Now that we are sure the measurements match with the scenario and we are able to do a prediction with it, we add 4 more user equipments to see if we can scale up a little bit. As new user equipments are deployed, after some synchronization latency, we are able to see them on the dashboard as well. As you can see, we have 8 user equipments connected to a single G-Node-B instance. Thank you for watching.